So if you have a series of functions and want to determine whether that series of function converges uniformly or not, we can use the Weierstrass M-test. So Weierstrass M-test is used to test whether a series of function converges uniformly. The statement of Weierstrass M-test is, so the statement let xd be a matrix space and f of n is a sequence of functions Now, if sequence of functions defined on x now if absolute value of f of nx less or equals to m of n for all n greater or equals to 1 and x element of x, and the second condition is summation of n equals to 1 to infinity m of n converges. Then the conclusion is then the infinite series of function n equals to 1 to infinity f of nx converges uniformly on x. So this is the statement of Weierstrass M-test. Now we will discuss one example to clarify that. So example, show that the following series converges uniformly. And the series is summation of f of x is summation of n equals to 1 to infinity cosine a to the power n by x over 2 to the power n. So this is our series of function, and we need to determine, or we need to show that this series converges uniformly. So what we will do, we want to apply the Weierstrass M-test, but to apply that we need to justify these two conditions. So first condition, to justify first condition, let f of n x is this part. So f of n is cosine a to the power n by x over 2 to the power n. This is our f of nx. Now take absolute value of f of nx, then it becomes absolute value of cosine a to the power n by x over 2 to the power n. Now we know absolute value of a over b equals to absolute value of a over absolute value of b. So this one can be written as absolute value of cosine a to the power n by x, absolute value of cosine a to the power n by x over absolute value of 2 to the power n. But for any values of any values of n, the denominator is always positive. So we can ignore the absolute sign. Now, we know the values of sine and cosine always vary from -1 to +1. So its absolute value would be always less than -1. So denominator is less than 1 and this is 2 to the power n. So our m of n is this one. This is our m of n. Now, second condition, n equals to 1 to infinity, m of n equals to 1 to infinity 2 to the power n. But this one is a convergent geometric series because here the ratio r is 1/2. So this is a convergent geometric series. So this one satisfies both conditions for Weierstrass M-test, both conditions. Therefore, we can conclude that this series converges uniformly. Therefore, by Weierstrass M-test, the given series converges uniformly. That's it. Thanks for watching.